Well, guys, what do we have here? We have the world-famous Little Moose. And what's that? That looks like a refractor telescope, a 150 fluorite that's going to be tested. We must be at the home of the one and only world-famous Jeff Blazey. Let's see what's up in his bag of tricks today.
Good morning. This is the unveiling of the Agema Optics SD150 refracting telescope. It's in a geoptic bag for protection. Jeff and I will unzip it, and Jeff will help me by supporting the front end while I put it on the table.
Oh, that's a beauty. Well, you know where my car is, Larry.
With rings and dovetail, it weighs approximately 32 pounds.
Beautiful. I should have went to the bank, Larry. Maybe I could take this home today.
It has a sliding dew shield, so it looks kind of short for an F8 when the dew shield is closed. The focuser rotates, and you loosen the lock for the focuser with these handles. And when I received the telescope, the spindle was not packed with it, so I had to attach that. And you can attach it in left or right sides as you wish to. So if you're left-handed or you just prefer it to be on the left side, you can do that. Cool. It has two bases for finder scopes because I asked them to give me a second one for the purpose of using a Teleview Starbeam finder scope, which I thought might be a little more comfortable to use because this is a long refractor and sometimes you have to crouch down to look at things high up. It comes with a sort of like a click lock.
Oh, that's sweet, yes.
To allow you to have perfect concentricity of your diagonals and eyepieces. That's very nice because I've had experience with other telescopes where you just have like one locking, and it will sometimes move your diagonals, particularly if it's got little undercuts in it. And although Takashi's pretty good, usually having two with those, and that helps.
Gorgeous.
And this is the 9th one made in the world. There's a 10th one coming though. Yes, not too long from now.
Now, how long did you have to wait once you put your order in?
Ooh, a very long time. But that wasn't, but if it weren't for a little mishap that I'm not supposed to talk about, it would have arrived a lot sooner. So it was 2.5 years.
Wow.
Yes, please open it.
3.
This beautiful scope is now set up in double pass Auto-Collimation, better known as DPAC. And we did this immediately. As soon, when you saw us take it out of the bag earlier, we put it into double pass immediately. Why would I want to do that? Because the scope was cool, and I wanted to show a demonstration of why it is absolutely necessary when you do a test like this that the scope be absolutely thermally stable. And by double pass testing it when it's cool, it's not thermally stable, and you will see artifacts, changes in the image performance and the figure of the lens during that cooling process. Now, when we set it up in double pass, let's scope up a double pass real quick. I wanted to look at the thermal response of the lens real fast, just as a demonstration to show you why you really need to let the scope thermally stabilize. So I took an inside of focus image in green light.
Can you bring that forward a little bit more, Jeff?
In green light.
Perfect.
With a 133 line per inch Rocky screen, which is right here, and a green LED. Now you notice immediately when you look at the top of the picture, the lines are bowed inward and the lines are bowed outward at the bottom. That is an indication that the lens is not thermally stable.
3.
And then to let it thermally stabilize, Tony, Larry, and I, we went out to have really nice lunch for a couple of hours. And then we came back and I immediately took another inside of focus green light image with the scope and double pass. And as you can see, now the lines are straight up and down. They're straight up and down. That means the scope is now thermally stable. And that's a really good result. These are very good. This is a very good green light image.
3.
Well, green light is interesting, and it's very easy to do with a green LED. What is much more interesting, gives me a lot more information as to the color correction of the lens itself, is to use a white light LED. When I use a white light LED, I get an image that looks a lot like this. And what it does is that with software, I can separate out the red channels, the green channel, and the blue channel. And I can also simulate the yellow channel. And that tells me a lot about the color correction of the lens. When you look at this now, you can actually see some little fringing in the blue and in the red, but that's minor. It's actually very minor. It's a very white image. That's why I take this type of picture.
3.
One of the questions that Tony and I got from our previous video that we did on double pass, one of the biggest questions was, where do you get the flats? Well, that's a good question. That's a very good question. Honestly, one of the best places to get them is just on the internet, eBay, but you have to be very, very careful. Now, for a double pass, you don't need 1/10 of a wave flat. It could be several waves off. It just needs to be smooth and regular with no astigmatism. The flat I used here, I got a long time ago from the late Ed Byers. It was used on a heliostat, so it's actually very, 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 very flat, like 1/10 of a wave flat. But I really don't need that. But as you can see, it's got some coating problems and stuff like that, but it doesn't affect the overall quality of the double pass image. Now, as an experiment, I went out and I got an 8-inch cheap flat I found on the internet for $35. They said it was flat on one side, and it does appear to be flat on one side and it's uncoated. So what we did here today, we first took our images with the good flat, and now we're taking our images with the, well, what I will call bad flat. And I can show you why. There's a stark difference between the quality of the images that you'll see from this flat and this flat. The image you're seeing now is the double pass image taken with the white light LED using the Ed Byers flat I had mentioned previously. As you noticed, it's nice straight lines from edge to edge, and that gives you an indication that the flat itself is of exceptional quality and quite good for use on double pass. The image you see now was taken through the inexpensive 8-inch double pass flat that I had gotten on the internet. As you can see, it's very, very different than the one that was taken with the actual flat that I normally use. This is not a good quality flat. You can get some good quality flats for a reasonable price and an inexpensive price on the internet, but you have to be very choosy about the flats you actually end up getting.
The objective of this refracting telescope is a fluorite doublet with the fluorite lens in the back. And one of the special designs of the telescope objective lens is that there is a specific air gap distance between the front and rear elements that acts as a weak third lens for improving the spherical aberration control.
All right, excellent. Appreciate that, Larry, for that input.
One of the things I check for every telescope that comes through is I check for the alignment of the focuser with the lens itself. The way I do that is I construct a paper mask the same diameter as the lens, put it over the center. It's got a hole in the middle of it because it was made with a compass, and then I stick a high quality laser in the focuser and then see exactly where the laser falls relative to the center of the lens. In this case, it's going right through the center of the lens. You notice Skywatcher 150 ED, well, it fits this one too, because it's a 150 millimeter aperture as well. This is an indication of really good mechanical design. We are now conducting the infamous green laser light test on a fluorite telescope. So what's so infamous about it? Fluorite is a crystal and has very uniform internal properties and does not scatter light inside of its structure. But glass does. So what you see, you'll see a thin green line on the front element going from the two dots on the two front dots. That's the non-fluorite element. That is the internal scatter of the laser beam through that element. But as you notice, the only thing you see after that are two dots or a couple of dots and no other thin lines. Well, the laser beam is going through the fluorite element, but it's so pure you don't see any internal scatter. And that shows you that the fluorite is actually the back element of this lens system.
And then also, Jeff, I'm noticing the two lights in the front, then a space, and then the two in the fluorite. So that space between the first two and the second two is the air gap, correct?
It's probably the air gap, yes. When the laser beam goes into the fluorite element, it will leave a dot. And when it comes out of the fluorite element, it will also leave a dot.
One thing I'd like to show is this really nice designed lens cap that came with this telescope. And you can see this nicely machined knob, beautifully corners, and the way it's designed, I really like that you can hold this, put it on the lens to protect it. And Larry was telling me when he received the telescope, this was off so as nothing would push against this in shipping. But I thought this is really a beautiful design. I love that. Okay, Jeff, before we get involved in having you describe to everybody what type of equipment they might need to do their own testing, could you give us an assessment of the SD150 F8 Fluorite Doublet that you previously did here today and tested? What's your assessment of the optics?
Actually, it's a wonderful scope. The spherical correction looks just about perfect. It's got a good smooth figure, and the color correction appears to be superb. When I was racking the focuser in and out, I didn't see any sign of astigmatism at all, and it's a wonderful sample. It's a high-end, high-tech, excellent example of fluorite doublet.
All right, Jeff, to start off, I see you have a regular cell phone. Could you please let us know why you prefer to use that?
Sure, Tony. I use it, because, well, look, it's very lightweight, easy to use. The optics are on the back. And this particular particular phone is one of my older phones that's since been retired, but it's got an exceptional camera and an exceptional menu, so I can get inside and I could do all kinds of manual things. I can choose the ISO, the depth of field, and shutter speed, color temperature, manual focus, and all that stuff. And it's got a pretty good quality camera lens as well. I do it simply and it's also image stabilized. It's actually a high-end camera, which when I retired the phone, I was not going to retire my camera because it's so easy to use. But you could use a DSLR, anything that can get you in close to look at the image on the wonky screen when you're doing double pass.
Excellent. Well, thank you, Jeff. Well, next up, Jeff, I see we have a power source with 2 batteries. Could you please let us know the reason for that? What is that doing?
Well, it's simple. Again, you don't need anything really complicated to do double pass. All you need is a little power supply here, which is basically 2 1.5 volt cells in a holder with a cap on top, and 2 leads that are soldered onto it with alligator clips, which, as you can see, I just clip into the LEDs. Now, this is a white LED. The LED in here is a green LED.
So, Jeff, let's talk a little more about these LEDs. Could you please describe to everybody where to get them? You know, just what are people going to know if they want to test to get LEDs?
Well, what you want to do is get onto the internet, because that's the best place to get these things. They're all over the internet. All you have to do really is to type in or Google green LEDs, red LEDs, blue LEDs, and they come in basically 2 different sizes. One's a smaller diameter one you see here, and here's a bigger one that you see here. This one happens to be yellow. And then you can also get, there's 2 standard sizes. I think this is like a 1 millimeter, 1.5, so it's like a 3 millimeter. And it depends on how you make your holders, which sizes you want, but they're quite plentiful. They come with, you can get them with either longer leads, shorter leads. In terms of voltage, you want them to be low voltage, but it also depends on what type of power supply you use. It could be anywhere from 3 volts to 10 volts, or you can even have a little rheostat in there for them. But it all depends on how you want to do your LEDs.
So if somebody wanted to be
plentiful and cheap.
Yes, so if somebody wanted to use the setup we saw previously, make sure they're getting a 3 volt and not a 10 volt, so that they're not that they got the proper power
Yes.
source for the LED.
But they're so inexpensive. Get a combination of voltages. They come sometimes in big packages. For $5, you might get 20 LEDs.
Oh.
So of different sizes and different colors and different powers. That way you can mix and match and experiment to what's best for you.
Excellent, excellent. While we're on LEDs, Jeff, could you give us a little bit more information, please, on those?
Yeah, sure, Tony. What I usually get is I get LEDs in different colors. I get red, I get blue, I get green, but I also get white, and there's also a yellow LED out there too. So so it's really very easy. Then I try to get LEDs with long leads, and then I solder on my own leads so I can use my alligator clips. That's a red LED, obviously. Okay. This one here is a blue LED. How do I know it's a blue LED? I've got my blue tape.
You cheated,
So
Jeff. You cheated.
It's a blue LED. Okay. Now here's something. Here's the white LED. Now something I really recommend for people is that when you get a white LED, don't get a blue-white one. Get a warmer color LED like this one. Why? Because a lot of digital cameras are hot in the blue. They have very sensitive sensors in the blue. And if you have a lot of a blue, clinical blue type of LED, it'll oversaturate the blue portion of your sensor. Try to get a very warm white LED, a warm light.
All right, Jeff, I see we have a high precision diagonal. Please tell us more.
Well, one of the nice aspects of double pass is that you can test for optical quality of just about anything that you put into double pass. So one of the things I have done in the past is I've taken all of my star diagonals. This one is an ASTRO-PHYSICS Max Bright Star Diagonal. And I put it into a reference telescope, which is my TEC 160ED, which is extremely good optical correction. And I can just put it into the light path and see if I see any difference or can detect any difference or photograph any differences
in the double pass performance of the system with and without the diagonal. And some diagonals do affect things. This is a mere diagonal. It does not affect the color. Some prism diagonals, I definitely see a color disturbance with the prism diagonal. But it also tells me just how good overall the optical quality is. The ASTRO-PHYSICS diagonals I use because they are superb optical and mechanical quality. I can put this into the telescope and not see any difference in alignment of the beams or anything like that. And I cannot see any difference at all in the optical quality, even with a white LED. So just for convenience, I put this inside of, I usually use this one and another one specifically chosen in my double pass work because it's so much easier to look down into the image of the Ronchi screen as this hunching over and looking through it. And these are basically optically invisible.
Excellent. Oh, thank you. And Jeff, as to these Ronchi screen holders, could you please tell us more about those? I see they're in some different materials. Please describe.
Sure. The idea of any holder, you can make them out of just about any materials. Here are two homemade ones I made from bits of wood I had sitting around and eyepiece adapters. I just very carefully lined everything up, and I, with my Ronchi screens, would slide into there, and my LEDs would fit into a small hole, just like you see here. This is 1.25 inches, and this is a 2-inch holder. These were made out of just bits of wood I had laying around. These are very nice, very precise 3D printed holders made by a friend of mine. His son actually made them for me. One was had with the small LED, the smaller LED, and this is with the 3mm LED. So if you have access or you're savvy with 3D printing, you ought to be able to easily come up with a 3D holder like this person did. And I've seen several people on cloudy nights on the internet actually do this. Mine, when I started out, I just made as precisely as I could out of bits of wood scrap I had laying around.
Excellent. Jeff, could you please give us more information on the Ronchi screens?
Absolutely. Normally for double pass, you use a Ronchi screen that has 133 lines per inch. Now you can't see the individual lines because there are 133 of them in lines per inch. You can also use 200 lines per inch. I prefer 133 lines per inch because I think I get a slightly higher contrast view that way. What a lot of people have asked, where do you get the screens? And that's an excellent question. These screens that I have here were sourced by a company called RonchiScreens.com. They are no longer available. But I have been making some contacts, and some people on cloudy nights have been sourcing their Ronchi screens of high quality from a company called AppliedImage.com at Applied Images at this phone number here, 585-482-0300. I have not purchased anything from them myself, but several people who I know do double pass work on cloudy nights have bought the products from them. So what you do, you go over here to products, you go down to Ronchi Gratings, click on it, and it gives you a brief description of the Ronchi gratings. Okay, they can be made on several materials, made on very thin glass, white opal of all things. And I haven't talked to them, but they may be able to actually print them out also like this on some sort of photographic film. Okay, transparency type film. The idea for getting Ronchi screens is you want a high quality screen, which means a smooth, sharp line. You can try printing themselves. You might be able to try printing it yourself on your home computer using transparency film, but you have to have a very sophisticated printer to be able to print something finely in sharp detail at 150, anywhere from 100 to 200 lines per inch. That's a tough thing to do. So you see here, they come what they call cycles per millimeter. But over here you see the material that it's made out of, which might be glass, okay, or it might be some type of transparency.
Real quick, would you
yeah.
recommend one over the other, or doesn't it matter as long as it meets the high
as long
quality?
as as long as it fits your needs, okay. I personally like the film type because it's easy to cut to fit the holder that you have designed.
Excellent.
Now that being said, if you also get a very thin glass one, you can just use a glass cutter to cut it to size too.
Excellent.
And they have overall different sizes. 2.5 inches, 4.5 inches. I mean, you don't need anything that big. 2.5 inches. They might be also able to do custom sizes for you too. But they also then the other thing is I said 133 lines per inch. They have resolution, and that 133 lines per inch is right around what they call 5 cycles per millimeter. You can go 4 cycles, but I would recommend the 5 cycles per millimeter. Now these can, if you get glass, chrome etching on glass, you can see that, boy, it's starting to become a little bit expensive. So I would always recommend going.
What's the price on that? I can't see it from
You
here.
see $110.
Oh, for one, okay.
Yeah, okay. So then I come down to size. Here's chrome on photographic paper, chrome on glass, and it automatically populates what's there for chrome on glass. Okay. Overall size, I'll go to 2.5 inches by 2.5 inches. And 5 cycles. Okay, they're starting to become somewhat reasonable. Okay, at $80 each. You can try Edmund Scientific Company too, but theirs might be just as expensive too. And this is for a 2.5 by 2.5 inch one. You might actually be able to cut that in half, so they're just $40 each. So that's a source that I've seen on the internet and cloudy nights for high quality Ronchi screens.
Ah, excellent. Very good information, Jeff. Really appreciate that. Now, Jeff, what kind of a tease is this?
Well, Tony, this is the tease of a cloudy nights coming attraction for a AP Starfire 110 GTX.
Shh. Mum's the word. I won't say a word.